using Taylor series. A Taylor series is of the form f of x equals the sum c sub n x minus a to the n. If a equals 0, then f of x is n equal to 0 to infinity. The sum of c sub n x to the n is called the Maclaurin series. The Taylor coefficient is the n derivative evaluated at a over n factorial. For example, write a Taylor series for f of x equals cosine of x at x equals a equals pi over 2. F of x is going to be the sum at n go from 0 to infinity, c sub n at the coefficient times x minus pi over 2 to the n. The c sub n terms are going to be the nth derivative evaluated at pi over 2 over n factorial. We start by taking the derivative of cosine of x successively, and we evaluate these derivatives at a equals pi over 2. F of pi over 2 is cosine of pi over 2, which is 0. F prime of pi over 2 is minus sine pi over 2, which is minus 1. F double prime of pi over 2 is minus cosine of pi over 2, which is minus 0, which is 0. F triple prime of x at pi over 2 is 1. The fourth derivative at pi over 2 is 0. So the coefficient c sub 0 is 0 over 0 factorial, which is 0. C sub 1 is minus 1 over 1 factorial. C sub 2 is 0 over 2 factorial. C sub 3 is 1 over 3 factorial. And C sub 4 is 0 over 4 factorial. We observe that the even coefficients are 0 out, and the odd coefficients are negative 1 or 1, starting with negative 1. And so cosine of x is 0 x minus pi over 2 to the 0 power plus minus 1 over 1 factorial times x minus pi over 2 to the 1 power plus 0 times x minus pi over 2 squared plus 1 over 3 factorial times x minus pi over 2 cubed. And we see that there is a pattern here. It is the sum in the denominator odd factorial to n plus 1. X minus pi over 2 and the power is also odd integer to n plus 1. This is an alternating series starting with negative 1, and so we would need negative 1 to the n plus 1. We can check by plugging n equal to 0, and n equals 1, n equal 2, and so on. Note that this is a Taylor series, not a Maclaurin series. It is centered around pi over 2.